Alrighty. Happy Tuesday. We made it. You all survived Snowmageddon, okay?
Yeah.
I was fine with the snow. It's the ice that got me. I was trying to shovel my way out after my Thursday morning class to get here, and I slipped and fell. Not even bad, but I'm an old person now, and it hurt. And then it hurt to sit. I was like, I'm just gonna go take some ibuprofen and lay down. Like I was not gonna drive an hour in while it hurts, sit in a comfortable chair while it hurts. Uh, but we got there. So, all right, these dates were all wrong here. I know that they repeat from February unless there's a leap year. And I don't know how I screwed that up. So let me go fix these here. 27 and 5, it's 4, 1, 3, 10, 8, 15, and 17. Okay, so those should be better here. Um, So we're a little behind. We didn't get into our containers yet that we wanted to get into. So we got to talk about the project. We got to talk about containers. Um, it's not going to take us all that super long here, so I think we can start that today. Talk about the project today. Recursion might take a little bit longer, um, but we'll get to containers today. So we'll call this a catch-up week, catch-up time, and then we'll throw this in here. Project one review and containers and recursion. I'll do 11 and 12, and we'll see how far we get here. Um, should be okay. So hopefully all those dates are good now. Put those back here. Yeah. Good afternoon. All right, so let's fire up Visual Studio. I'm going to go look at the project. All right, that's why I had so many emails with submissions. Okay, I got it. It's like I'm getting email after email after email after email. So writing our class and test cases here, right, for all this fun stuff here as we go. So let's work on this one first, if Visual Studio will load. Console app, we'll call this project one. Now, I'm actually going to uncheck this box because it'll make the unit tests look nicer. Because then I'll have a folder for my solution, and then I'll have a folder for the project, and I'll have a folder for the unit test within that. It'll be a little bit nicer ahead of time. So it's project one, but then I'll have project one and unit tests is all. You don't have to have it like that, but this will just help keep it a little bit more organized as we go. All right. And we don't actually need anything in main at all here because we're going to unit test our code here. It's all a bunch of classes. So we're going to go add a new header file here. And again, I'm being lazy. I'm putting all my implementations in the header file. I've acknowledged it's bad. I'm sorry. I'm just going to keep repeating it here as I go. So we'll call this one unit. And we can have, oh, that's too big. We can have our class for units. Trying to think, yeah, we need the namespace, right? Because we've got strings. Yeah, we'll do using namespace standard and include string. Okay, so then class for unit here of our private section and our public section. So we have a bunch of private attributes for unit, right? Looking at this sort of UML style diagram, here's all the attributes. We didn't have any functions. I'm sorry, here, these ones are the functions here. So attributes first and then functions. We'll just go drop these in here. So we're a little bit backwards though, right? Because UML is backwards for fun reasons here. So init for attack power, great. Init for hit points. Now, interestingly here, if you need to keep your hit points between 0 and max, you probably need to know what your max hit points are, right? So it wasn't specified here, but thinking about how I can go change it or keep it between max, that's the sort of thing you're going to realize, oh, wait, I need another attribute here for max hit points, right? You might have found a way to do it without, but that's probably the easiest way here. Okay. Oh, you could like make a new unit and see what its hit points were, but that gets real messy for that sort of thing. A double for range. It's going to be square root of 2 to start, and then ints for x position and y position. Now, some people like putting these all in one line. I'm not some people. I very much like having them all in their own line. I don't care. If you put them all in one line, that's fine too. Some people think that's better. Sure. Doesn't matter one way or the other to me. I just like this way. And then this Boolean for is alive. Um, Now we can use this one here. We could also, and if you went that route, that's fine, turn this into a function. Because really this is, do you have any hit points? If your hit points are 0, you're not alive. So it's calculatable, computable, right? Rather than storing it as an attribute, because then you have to remember to change it all the time here. So if you did move that to is alive over here, is alive, and you just return hit points not equal 0, I'd have been great with that. And I think that's probably even easier. Just saves us a little bit of time. Okay. And then functions. A virtual function, we want this to be overridden by our child classes attack that takes a unit pointer, we'll call the target, right? So on a virtual function, we'll call attack that accepts a unit pointer as the target here. And we don't have to do anything with it yet, but that's okay. Void. Right, there's no return type on this one. And then move. So and then we'll also have a virtual for move function. Oops, void. We're not doing anything. We're not returning anything here for move. We don't really know how units move right now. Other classes have their specific rules around move. Right? Now, we need to figure out what makes sense for these ones here, right? If these are private, we need ways to go and change them here. But we don't always have to go set these things, right? If hit points should be between 0 and max, right? And there's a way to like deal some damage when you're attacking, we're probably not having a public function for set hit points. If you went that route, that's okay. It didn't say you had to, but I think it doesn't make sense to call it set. That's not typically how this sort of thing works here. Um, for range, this is going to be set once and stuck there. Right? There should be a way to change your range, so it probably needs to be something that's passed into your constructor. Pack power doesn't seem like it changes ever, so something in the constructor. X and Y's change based on move. Right? Move will move you a certain way. Right? Not you just go change your X and change your Y. So we don't need sets for those. Your team doesn't seem like there's a way to change that. We don't need to worry about that. So most of these then just have gets, right? So we can have our get functions for those ones. And again, I don't want to have to go write all that here. So let's just go ask our chatbot here. Right, get functions for this class. And I would paste in the whole thing, but I'm feeling lazy. Sorry. And GPT prompts, right? Get functions. Right. Is that okay? And we've done it before. We would have the rest here. Getter functions. Okay, now we get a bunch of get functions. I don't want to write those myself. Is that fair? I hope you didn't write them yourself. That's just a big waste of time. Look, it didn't give me the stupid comments this time. Last time it was giving me all those stupid comments, right? Oh, it started here with the getter functions. There we go. That's very useful comment here, right? You didn't know that this was a getter function, or this was a getter function. Very helpful for you. Okay, so we got our gets. So again, none of those things really set, but if we don't have a public set, we need a way to pass them into the constructor. So we need a unit constructor then that takes a bunch of values here. So we need an int for attack power, an int for hit points, we need a double for range, but that should default, right? So we need this to be a default option here. So that shouldn't come not at the beginning here, unless we're also defaulting X and Y in team. We have string for team, and then a int for X position, int for Y position, right? So in here, then we can default range to square root of 2 if we want it here, right? Then it's a bunch of this dot attack power, this arrow attack power equals the power is the attack power, and this arrow hit points is the hit points, and then my max hit points, right, is the hit points. So I'm assuming you probably get created at max hit points. Maybe that's a bad assumption, but that's what we're going to go with for now. We have a this team is your team. We have a this X position is the X position. We have a this Y position. is the Y position, and then this range is the range. Okay, so we'll go set all these things that we don't have other set functions for. Right? The constructor's job is to give all of our attributes values. Right? And if you don't have a public set function, you can't take a default. Right? It's just not going to work for you here. Okay. So unit, kind of close, right? But not quite done. So the virtual function, right? See if they're within range, then do this, and then we attack. We reduce their hit points by the attacker's power. So if we don't have a public way to change their hit points, we need a way to do that. Right? So we need a function like void, take damage or something here that takes damage. And this will change my hit points then. So my hit points minus the damage. And then I'm going to check, hey, if my hit points is less than 0, we'll put hit points back to 0, right? Because the idea is that it stay between 0 and the max. Now, also then we can check, right? I guess else if my hit points is greater than the max hit points, right? We'll set hit points equal max hit points. Max hit points. Right? If you didn't have this, that's okay, right? Hopefully you had some way to give them back hit points. I just know if you pass a negative number, now you're going to go positive, right? That's an option, right? Lots of ways to go about it here. This seems like it'd be useful to have to take some damage for a unit. Okay. So then attack, right? We need to see, are they within range, and should we attack them based on our team? Right? So if that's two different things, we can have that. So we'll just make that a private function here. So Boolean is within range, given a unit pointer to the target. So we can just compute it here. So if you're going to say if something's true, return true, don't bother, just return it, right? Save yourself the typing here. So we're going to take my x position plus their targets get x position squared. So more sets of parentheses. Math.pow, is that what that one is now?
I think so.
Yeah, there's no shortcut for that. That's obnoxious. Include math.
I think it's CMath.
Yeah, or I could just multiply by this again too. Is it math.h or cmath? Is that what you get here? I think both work. Trying to remember which one you usually do. I don't know. So math dot. Is it not doing it for me? Did it really cmath? I thought math h works. That's a blur. Cmath. Sure. Math dot? I'm getting nothing.
Can you just do how?
It's just there now. Yep. Thank you. All right. So the double to what? Is it x is the power? Oh my goodness. Power. That one. Another set of parentheses, comma, 2. Right? Is that the right one? It's terrible here. 4 overloads. None of this is helpful. Left and right. That's probably the right number here. Anyway, so that square root squared plus the power of the y position plus the targets get y position, y position, y position, all of that to the power of 2, another set of parentheses. Goodness. So those two put together then, the square root of all of that then, right? So the square root of that is that range greater than or equal to this thing here. Goodness. Square root of the power of that, okay. Right? That's our basic triangle. Okay, so now we have a little helper function for it. So then we probably want another one like should attack here. Right? If we're just going to combine it, you don't have to put these in separate functions, but again, a little overkill is nice here for illustrations. Should attack a unit target, we'll call the target, or unit pointer, we'll call the target. So we're going to return self dot. This is our team equals chaotic. Right? If we're chaotic, we're attacking anybody every way, no matter what. Or, yeah.
So does this have to be in private?
No. Uh, if it's not specified, usually if you're adding stuff, you probably want to make it private. Just that idea of encapsulating all of our details and giving someone an abstract interface to work with. Do they really need to know if my unit should attack another unit? Probably not. Not wrong to put it there, but just limiting what's publicly exposed is usually best. So if we're chaotic, or my team is equal to us and the targets.get team is equal to them, right? Put that one in parentheses, right? Making sure we're ORing these properly here. That one ended together, right? So if I'm chaotic, I shoot, or if I'm us and they're them, I shoot, or if I'm them and they're us, I shoot, right? If any one of those is true, we shoot. We should attack them, right? Okay. So then to attack, right, we're going to say if is within range, given the target, and should attack the target. If we are, then we'll do target dot take damage, given our attack power, right? So reduce their hit points by our attack power. So again, if you had a set, you could do the set. You'd have to get their hit points and subtract my attack power and then set it to that value. That'd be okay too. But again, setting doesn't feel like it's a good fit for this one here. Okay, so we've got attack. We've got virtual move. We don't know anything yet about move. That's okay. Don't really have a good way to do that one here. Okay, so far with unit? Right. So now we need to know, does it work? Right. So all the gets are really boring here. I'm not super interested in those, but the attack probably should do something, right? So we want to test that one, right? Any code we wrote is worth testing. And attack will use take damage. It will use my should attack. It will use my within range here. Okay, so let's go write some tests. So we're going to go up to my class here and say go to, oh my goodness, no, it doesn't do that one. I forgot. I'm going to go to our project. And I'm going to add a new project here. We're going to add the test project, the native unit test project. Okay, and sure, unit test 1 is fine. We'll create that one here. Excuse me. Okay, so from here, then we're going to include dot to go up a folder slash project 1 unit H. Right. This way, they're all in the same. Sorry, I can show you this in Explorer here. So I've got a project 1 folder for my solution, that is the solution file, and then a subfolder for the project with the project code and a subfolder for the unit test with the unit test code. It's a nice way to organize it here. Whereas the other one here, we ended up with like unit test being in a weird spot here. Set in inheritance, like we had unit tests inside of that, but not in this one. It's okay. So like some was subfoldered and some wasn't. It's not the biggest deal, but it's however you want to go about it. Oh yeah, we ended up with unit test 1 here for this one. That one was ugly at the same level. It was no fun. So putting it in the folder is nice. So we're going to go test out unit. So test method, this is testing test unit attack, right? And we're going to arrange, we're going to act, we're going to assert. Okay, so variables that we need, right? We need a bunch of things. We don't really care about most of them except for hit points, right? So I need a unit. We'll call this one the attacker, right? And these should be pointers, right? At least the target needs to be a pointer, right? So when I pass a target here, it has to be a pointer. So we'll make an attacker. We can make them both pointers, right? Why not? So unit attacker equal to new unit. We have to give it a couple things, right? So I need to tell it its attack power. So if its attack power is 5 hit points, team doesn't matter, X position, Y position, and range is square root of 2, that's fine here. And then a unit pointer for the target here is a new unit, 5 and 5, and team does matter here. Oh, that's right, so we do care about teams, so maybe an us and a them. And then if they're at 1, 1, that should be the square root of 2, right? So it should be within range here. So I should be able to hit them. And if I'm doing 5 damage, right, they should go down to 0 hit points. We could even check that, right? We could do, maybe if I have 10 attack power here, they should still stop at 0. right? If I want to check out, does that if block work here? So I'll have an int for expected hit points is 0. We're going to act. Let's call the code. So we'll say attacker dot attack target, and then an int for actual hit points. Actual hit points is my target get hit points. And I'm going to assert, do they match? Right. So this is assert colon are equal. Yep, there we go. The expected and the actual. Oops, expected hit points. There we go. Right, did they match? Now, if you don't have Visual Studio on Windows, you could do it in the main method. You just have to go and, if these match, then print test passed, else print test failed, or if you wanted to do it there. It's just a little uglier here, and then you don't get any of the fun stuff here. So in Test Explorer, we'll go ahead and run it. It should go ahead and discover our tests. It's really dry lately. Goodness, with all the cold. And look, our test passed. We're excited. You're excited, right? It worked. Life is good. So I feel like it's probably doing pretty close to what it should be doing here. Now, we didn't test all of it yet, right? We didn't make sure we don't attack somebody, right? Because we've got to check here, right? Technically, that line of code is running, right? This line of code ran, but did we test, is it doing all of the things it's supposed to do? No, I don't really have a great feeling for that yet. So I know I got back a true, but am I going to get back a false at some point? Am I going to get back a false within range here? You could go crazy with tests, and I could write 50 different tests here, but I want to make sure that I am within range works and that I'm not within range works, right? So I'm going to do another one here. So we just copy this here. This is attack works here. Sure. Go copy. So if you stopped at this one, I'm okay with that, right? It's probably better to go make sure this is correct here. So won't attack out of range here. So if they're at 2-2, then my expected hit points should be 5. That's it. I just have to change a couple things. So it's a lot of copy paste, right? We give it a try, and their hit points is still 5. Life is good, right? They kept the number of hit points they had because I didn't attack them here. So I feel good about that one here. Won't attack out of range. And then how about we also test won't attack same team, right? So for both us's then, and we're at 1-1 here, it shouldn't attack. We should still have 5 hit points, right? Let's go test that one out. So, and just being thorough, trying to make sure that all the things we wanted it to do, it does do here. And all the things we don't want it to do, it doesn't do, which sometimes is the bigger list, and that's okay. Right, so we've got unit. Feel pretty good. Move doesn't do anything, so I don't think we need any other tests. We could test the constructor and all the gets, but that's really boring. I don't particularly care. I think I told you that last time. Right. So then infantry, extending unit. It has a specific attack power hit points and a specific way to move. Okay. So if move is virtual, we need a way to be able to change its behavior for move here. Where does our move go here? Yeah, virtual for move. All right, so we're going to go add another one. Now, I like one class per file. Again, that's just me. So you don't have to do it that way. You could have them all in one if you want here, but I'm going to do one per file because it entertains me here. Here's infantry. So this is going to import unit, include unit, sorry. Include unit .h and using namespace standard. Oh, we shouldn't need any of that, right? Because we get it from the unit file, I think. So class for unit then, I'm sorry, infantry, tree, private section and a public section. Now, what's different about unit? Well, we know what its attack power and hit points are, and then it has a specific way of using, or of moving here. We're going to have to override move. Does attack work any differently? No, it's virtual, but we don't have to override it if it does what we want it to do. So we're going to change our constructor here so that we always have 5 attack power and 5 hit points, right? So I'll have a constructor then. So this is an infantry constructor. Now, what do we need here? Right, so my main infantry, my unit, needed attack power and hit points we know. So we need a team, we need an X position, a Y position, and I know what my range is, right? So I only need a couple values here for infantry. So I need to call my superclass constructor, right? So that was it unit colon unit? So was that right? 5 and 5, team, X position, Y position. Range was fine. Wait, is this how we did it? I don't even remember. I think you can also use the colon over here, right? Is that it? Unit? Yeah, I think we did it that way, right? That was the other syntax. Okay, we'll do it that way then. I think both ways work here. Unit colon unit? No, didn't like it. Just say unit. Oh, I never inherited from it. Inherit from public unit. That would be helpful here, right? If we told it we inherited. There we go. Now we'll say, okay, pass these values up. Okay, look at that. We can write code eventually. That's it. Nothing else special here, right? And then a void for move. Now, this one gets a little weird, and I was expecting more questions, but I don't know if you guys just don't like to ask me questions or if you just assumed you knew how it was supposed to work. But you can either move X or Y no more than 5 units. So to get that information, we have to be given it. So we probably need that to be passed in. So I think it makes more sense than if the virtual function takes an int for X and int for Y, right? Wasn't specified, but it's one of those things that, hey, we got to think about it. What makes sense here? Okay, so if this one has an X and a Y here, and this is an override, right? Now I can move given X and Y here, right? So we're going to check if X does not equal 0 and Y does not equal 0. Well, then bad stuff happens here. We'll raise a, I don't know, some sort of exception, throw an exception, bad exception. There we go. What is invalid? Is it an argument? Invalid argument. But I have to like go include. Jeez, that's awful. Include standard exception. Sure. Invalid argument. Can't move both X and Y. Sure. Why not? And if you didn't throw an exception, that's okay. I don't think I specified it should throw an exception, but these are things we've done before. So we have learned them. We're probably going to keep doing them here, but wasn't point specifically for saying use an exception here. So either X or Y, no more than 5. Okay. So if they're not zeros, great. Then if X is greater than 5 or X is less than -5, right? Can't move that far. Can't move far. Right? I guess we can throw in the y's as well here then, right? Or y is greater than 5, or y is less than -5. Should we do like the absolute value of y? That sounds better, right? We already have math. I think we already have math, right? Abs x greater than 5 or abs y. Look at that. We saved like an inch of code of typing here. I already typed it and I had to erase it, but this feels better, right? Does that feel better? Okay. We like that one here. Can't move that far. Otherwise, then I'll take my x position. No, you don't have access to x position, right? It's not public. I can't go change x position. I can't go change y position. I've got options. We could go to unit and make that protected. There's the protected level, which says your subclasses have access to it, right? Or we can make this one actually go and change and just override it with the checking here. Which way do you want to do it? Protected? Okay, I like it. So we'll add a protected level of values here, and we'll put them in protected. Where to go here? There we go. So now when we go to move, I can say, okay, x position, and now I have access to x position, plus equals the x, and a y position, plus equals the y. Now I don't know which one's which, but I know they're one of them is 0, right? Otherwise we would have had an exception. So great. I can just add them to both, and it might not do anything, it might do something, that's fine. Why is that one gray and this one not gray? That should be gray. I think it's just Visual Studio being dumb. Yeah.
Well, one thing on an option you said it was either move the attributes or
So this one doesn't have to do nothing. This one could go and change them here at this level if we want it. We could say, hey, x position plus equals the x and y position plus equals to y. And then we could just call our superclass version of it here. Right? So this is protected access, protected access. Otherwise, then we could say, hey, I want to use my unit colon move given x and y, right? So I'm overriding it, but I'm still going to use it this way if I want it here, using class version. So it's probably better to do it this way and override it with protected and not have the logic be here. I don't know. Totally up to however we want to implement it here. So that's, optional. I'll just leave that commented out for now. Okay. Does that make sense? So what do we need to test here? Well, move. That's the only new code we wrote was move, right, for infantry. I know it's got specific values. We could test one to make sure we passed it 5 and 5 in the right order. That's probably a good thing to do. I'm just feeling lazy right now, so I'm going to skip it. But ideally, we got to test for that. That yes, we passed. Now, and 5 is even ugly here too. Like, it would be better to have those be static values probably, right? Let's have I don't know, attack power is 5, int for attack power, constant int attack power, right? We can make those constant int hit points is 5 or something like that. You could use attack power and hit points. Right, this is probably better, right? Let's try some good habits here. Okay, so we want to test it. So we'll go to our unit test class here, and then if you want a unit test per class, that's probably a little excessive. Sure, I don't know. I say I like individual classes here, but then I do different ones here. Project 1, infantry. Let's go test infantry. So this is test unit, test unit, test unit, but essentially the same idea here, right? We'll copy paste in, maybe down at the bottom. This is test infantry move here. So we're going to arrange, we're just going to use an infantry, we're going to act, and then we'll assert. So we need an expected x position, int for expected x position. I don't know, if we move 1, we go 1, right? And an int expected y position is 0. And we make an infantry. So infantry, I don't know, we'll do pointers. I don't think it adds anything to be pointers, but why not here? Infantry, so new infantry, and we give it then the team. Team doesn't matter here. We can just give it an empty string here. And if we give it 0, 0, all right, we've set it all up. Now we're going to act. We'll call our infantry move given 1, 0, right, my new x position. Don't move y at all. And then we'll get our actual x position. Here's my infantry get x position with some parentheses there, and then an actual y position. I'll just copy paste, get the y position. And then we can assert. Assert : it's capital A, right? Assert : are equal my expected x position and my actual x position, and then we'll copy paste for y position, right? So it should have moved x here, right? And not moved y. Should be good. Okay, that one seemed to pass. Now, it shouldn't let us do other ones here, right? So we've got our, I think there's a nice way to test for exceptions here. We're just going to cheese it. Is that okay? I don't remember if we looked at that before. So I should be at 0, 0 if I screw this thing up here. So if I try and move 10 here, so I'm going to put this in a try block here. And then we're going to catch, what do we want? An invalid argument. I don't know, EX, sure. And then we can say, hey, here's my string for error. Starts off at nothing here. And then I can set my error to ex.what. And I can have a string for expected error is, I forget what we set it here, right? Can't move that far. Can't move that far. So we'll try, we'll catch, and then we'll assert my or equal my expected error and my actual error. What did I call it? Oh, it should be actual error. And the actual error, right? Did they match? This is cheesy, but it's going to get the job done here. I think there's a nice way to do it with the assert library. I just don't remember how to do it right now. I don't want to Google. Oh goodness, build errors. What do we do here? Member function. Oh, I forgot to change the name of it here. Test infantry move. This is won't move too far. There we go. Hey, we won't move too far. That passed here. All right, and again, one more time then. Copy paste, won't move both X and Y. Sure, why not? So go copy our error here. Can't move both X and Y because I don't remember. So if I try and move 10 and sure, it doesn't matter, right? Because it's going to check that one first or not. And then I'm also checking it didn't actually go anywhere, right? It stayed at 0, 0 where I put it here. But raise an exception. Oh, that's the wrong button here. I don't have any main code here. Test Explorer. Run tests. Hey, you okay so far? All right, awesome. All right, think we're good with infantry? Then artillery. Basically the same thing, but move is different now. I feel a little bad, but that's okay. All right, let's go for it. Let's go add another header file for artillery. Artillery. And then I'm just going to go copy paste from infantry here. And then things that are different then, right? They're these fives, right? Should probably be another attribute here. So constant int max move is 5. I don't know why I like the number 5 everywhere, but apparently I like the number 5 everywhere. Max move, max move. And then I can say, hey, this is a artillery. Oh, actually, let me go copy paste this one back because I like that change there. Then we'll put it back in artillery. Artillery. Now its attack power was 10, its hit points was 1, and its move was 1 or something. Isn't that right? 10 range. Oh, and range. There we go, in range. Constant int range was 10. So we're going to pass in then. Oh, that should be artillery. Double click, please. There we go. So we're going to pass in a range of 10. We should do range, right? Range.
Should a range be a double?
Yeah, thank you. So yes, it'll fit as an integer because ints are smaller than doubles. You could pass an int in place of a double. But yeah, it probably should be a double. It's going to be a little nicer. Um, I think all that same stuff is here, and then it moves one at a time, right? Oh, we didn't have a. I didn't specify hit points. Oh crap! Oh no, I did specify hit points. Hit points 1. Okay, it's going crazy, right? And then move is really the same thing here, right? Okay, cool. So not really a whole lot to test. We could test the move if we wanted, but now we're feeling bad because we have the same code twice, right? Couldn't we just do this in the parent class if we tell it what its max move is? I'm glad you asked. What a great idea. Right, let's do that. Let's put that in our parent class. So we'll just have this here then and move it over to unit here. And then we'll have to define, so instead of max move here, we'll have a max move value. Oops, that's probably the wrong move and a max move. It says, well, what's my max move? I don't know. Let's go figure it out. So let's go add another attribute here. Probably make it protected. I don't know, in case we wanted to change it here. And we'll add that in as an argument here. Int for max move. And we'll probably default it to 0 until we know otherwise, right? You just can't move at all until you tell me. It's probably fine. And then go change infantry, right? So I don't even need this move function here at all. I don't need to override it at all. I'm going to pass in a range. I should put it in the other order. That's fine. We can pass in square root of 2 and then 5, right, for max move there. And then for artillery, right, we're just going to pass in, we already did range, and then we'll have a, oh, max move. That's where you go. We have an attribute for it. There we go. I think we have that max move. Feel bad with that default here, but that's okay. Not too big of a deal. Right, but now all my tests should still pass because all the same code's still there. It's not even really testing infantry now, though, right? Uh-oh, infantry move. Unhandled exception. Where did we get an exception? Infantry. Really? The other one's passed though. Move line 69. You can't move that far. Oh, I never set max move. We took it as an argument. We never set it. So this max move equals max move, right? That ought to fix it here. Now, what does it not like about unit? Uninitialized. Max move. We just did it. Okay, it's just Visual Studio is being slow. Now let's try it. See, that was good. It caught a problem. It tried to be clever here and didn't work. Oh goodness, really? Unhandled exception still? Can't move that far? Are we setting max move? Do we not pass in max move for infantry? Max move is 5. Looks like we should have passed it in. Now I'm curious. Okay, well that's fun. This is a good example. Let's go to our unit tests here, and this is test infantry move. Let's put a breakpoint in. Let's run in the debug mode so we can debug our tests here. This is why it's nice too. We don't even need the main method to debug here. We can debug right in here. So here's our infantry class here, right? It is a unit here, and its unit values, then it's not set. Value of max move is not set. How's the value of max move not set? Didn't it get set here in unit to max move? It's warning me something. Oh, okay, let's put the breakpoint here then. Let's try it again. Go back to Test Explorer and debug it again. All right, so we're calling the unit constructor, right? And when we step in to our code, our max move is uninitialized. Where's our values here? Doesn't have a value. How do we screw that one up? Mech power. And hit points don't have values either? Really? Wow, none of those have values. Oh, putting them up here didn't work as constant ints. Why didn't that work as constant ints? Do I have to say static? See if that works any better. Yep. So if it's not defined as static, it was initializing these after parent class constructor as the order in which things are initialized. So when you create an instance, it does the superclass init first, constructor first, then it was setting these. But if I say they're static, it gets set once at the class definition level ahead of time. When we compile, it gets set. That's obnoxious. That's fine. We can go do that.
So Professor, I have a question.
Yeah.
So if you go back to what you were just saying.
Yeah.
So you need static.
So that they're
like the sub classes.
Only if you want to use that value in the subclass superclass init here, because the way that the order in which they get set. So I don't know if you saw when we were stepping through, it didn't set the value until we came back from the unit class constructor. So this constructor runs, it calls this constructor, then it runs, and then these things get set. So this is also why like setting these things in definitions here rather than constructor are ugly, right? Why is it not like that? Can't have an in-class initializer? What? Wait, oh? What is it not like? A member? Can I have an in-class initializer? Are we doing that differently somewhere? Or not, right? I think that's just being done. Is it gonna build? Yeah, I think it builds. Yeah, okay. I don't think that's actually an error. It's weird. Member of type const double cannot have an in-class initializer. And why is it still upset about this one here? Maximum. Okay, that one went away. Okay, now it's still there. Let's see what the internet says here. Why is it only the double? We declare. All right, I think it works anyway. That's super weird.
Explanation wasn't very helpful.
It's anything that's like old standard things are really weird. And if it's in the class, like the order which you initialize it here, and if you have your header file versus your implementation file, it can get kind of weird. Oh, but that's lame. Constant expression, and now it compiles fine in C++ 11 plus. Okay, sure. Constant expression. Nope, we don't have access to that. That's fine. We'll just ignore it. All right. So now though, artillery and infantry are kind of boring, right? They just don't do anything here. And I don't even need move defined at all. I don't even want move defined at all because it just works here. But sure. And then cavalry is going to be just as boring. So again, if you didn't do it that route, that's okay. Right? I'm just, as we're working through it here. So this one now is 10, 5, 5, 10. Here as we go. So let's make another class for cavalry. Cavalry. And we can copy paste that in with our other one here, right? It's the same thing here. And this is cavalry. I don't even think we need exception here, right? We just need unit. We don't need primary once, twice. So max move is 10. Hit points is 10. Attack power is 5. And range is 5. Right, and then this is cavalry. No, stop. Oh my goodness. All right, we'll do it the old way. You can't double click. Cavalry, why? Hates me. Great. Cavalry's good. Nothing to test. Kind of boring now, actually, if we do it with that much inheritance. But that was sort of the idea. If you find the right way to override these things, you don't have to do any extra work. If you did it the harder way, well, sure, you did some extra work. That's okay. Maybe that was learning. And then captain is an infantry. So this one is definitely different, and their attack is different here. So captain will extend infantry. So let's add a new class for that. Captain. So we're going to include infantry. Infantry.h. And a class for captain. A private section and a public section. I don't actually know if we need all of that here, but that's okay. So what do we need? Captain extends infantry, public infantry, right? So we got a specific attack power and hit points. Okay, let's go get those then. So infantry, attack power and hit points. Move was the same, right? So we said attack power was 1. Doesn't actually matter here because we're not going to do that, but hit points was 20 here. And we're going to change the behavior of attack. So we're going to have a void for attack given a unit pointer called the target here. Okay. Now we still want to know if they're within range. Right? Do we get a range? I don't think we changed our range here. So we still range of square root of 2 is fine. We need to know if they're within range. So easiest way to do that was to move this from unit to protected, right? So we have access to it. I want to be able to use this in my subclass. I don't want to have to reinvent the wheel here, right? We can do that. But then the should attack doesn't work, right? Because we're only looking for same team, right? So we can say if my is within range of the target, and then if they're my team. So if the target.get team equals my team. Now, yeah, get team, sure. I can use my get team. If that's true, then I'll take target dot, I don't know, we can do damage, take damage of target dot get max hit points times -1. Give them negative max, should put them back to max. Right? A little cheesy here, but it should work. Right? But we need to instantiate ourselves with more hit points here, right? So we need a captain init function here. Now we still need what, a string for team. We need a int for x position and int for y position, right? And we need to pass all that to infantry. So infantry needs the team, the x position, the y position, team, x position, y position. Oh, but this is not going to let us give it hit points though. Kind of a bummer. So we could either let that be passed in or give a way to change that to other classes. Might make sense for protected access for this here. And again, there's not necessarily a wrong way to go about it here. But if we want this hit points to be able to change, right, we should go make these protected here. So this is allow captain to change. Sure. So we can then go to make my hit points. Hit points is hit points, and my max hit points equals the hit points. Not the most pretty solution here, but it gets the job done. And then attack power, we also could change to 1 if we wanted. We never actually really use our attack power, so I'm not super concerned if we use that or not. But we could also make that protected if we wanted to change it here. So instead of having to pass everything through these constructors, we could go and set them. But most of the constructors have things we want to set. Right, so the last thing we have to do is go test it here then. So we're going to test our captain. So test captain heal. Now, this one we need a unit that's damaged to go back up in health. Right? And captains can't do damage to units, and units should be able to damage themselves. So we're going to need a couple different units here. Right? So we'll do infantry on us. This is the attacker. And then we'll have a target, infantry. Actually, let's put them on the them team here because we want to be the us team, of course. A target. No, attackers us. No, that's fine. Okay, sorry. I'm confused here. Infantry of us. And then we'll be at 1-1 here, so we're within range. And then a captain. Oh, we got to include captain. Include project 1, captain.h. Help if you could spell include. There we go. Wonder why the typepad wasn't working. All right, so we're going to make our. Oops. Yeah, we don't have this infantry. That's okay. So we're not going to do any of that here. I'm going to do this here. Okay. Captain equals a new captain. We should make that a pointer, right? Just for fun. We're doing all these pointers. Captain then should be on the us team, so it'll heal them. And then if they're at 2-2, they should be within range of healing the target here. So then the attacker should attack the target. Infantry have how many hit points? I don't even remember anymore. 5 hit points and 5 attack power. So it should take them down to 0 here, right? Now we're testing if captain heals. So we'll have an expected hit points. Expected hit points is 5. Can we make him attack someone else? That's fine. We'll take our captain dot attack the target here, and then an int for actual hit points. Then we'll be like target dot get hit points. And then we can assert the are equal the expected hit points and the actual hit points. All right, let's see if that one runs. Should have killed them. We brought them back to life because we're magical like that. Uh-oh, it didn't work. Expected 5, actual was 0. Okay, well, let's see what happens. So, captain in the attack, if they're within range and their get team equals my get team, we should have them take some damage. Max hit points times negative 1. I don't know. Let's put a breakpoint in. Let's see what went wrong here. So I think that should work. We don't need a breakpoint here. We'll continue. All right, so we're attacking. So this is our captain. We're going to check if we're within range. Oh, apparently we're not within range. Or the team was wrong. Okay. And let's go back here, and let's step into our code instead. Step in, so it is within range of the target here. So my target is at 1, 1. Oops, where did that go? 1 and 1. Oh, I pinned it. And this, my captain, is at 2, 2. That should be fine. What's the captain's range? Square root of 2 should be okay. So let's step. We got back false. What did we do wrong here? Targets, get position. Is it not plus? Is it minus? It's minus. No? Oh my goodness. My math is so bad right now. It's minus, right? Not plus. So we didn't get that because we never had the range being other than 0 to 1. Interesting. Well, that's fun. We found an error with our is within range that we didn't know before. Look at that. So we had a bunch of tests. It looked like it was working. Y'all thought it was working. I thought it was working, and it did not. Good to know. Good to know. Okay, bugs happen.
Good to know.
It is. It is. All right. Sounds good. We got our tests here. So let's take a look. We've got unit class and tests, infantry class and tests, cavalry class and tests, artillery class and tests, captain class and tests. I mean, we actually were able to skip some of these because we put it all in unit. And I thought that was clever. If you thought that was cheating, my apologies. Hopefully you would have asked me. Nobody asked me if they could or not. I would have said, go for it. Save yourself the time, right? Any code you have more than once, if you have code more than once, you should feel bad about yourself. Good rule of thumb. And we don't want to feel bad about ourselves, right? Because we want to be efficiently lazy. So, project 1, that go okay? All right, cool. Let me push that. So here's project 1. And push. All right, so what else were we doing today? We got to talk about templates, right? Let's see. No, not templates. This is the containers, right? We just updated this. Here we go. We'll look at it in here. I don't know why the canvas is slow. Okay, yeah, containers for ADT type, and then we can work on recursion later. So we'll look at chapter 11 in our Zybooks here. Containers. Really? That's okay. I went to this at the beginning of the semester and I've forgotten already. This one is not interesting at all. Other standard template library containers we can use. So we did this ranged for base loop. We've done these enhanced for loops before. I think this is what your guys were confused about at the beginning of the semester. Some people said they'd never seen them before. It's essentially a read-only loop. So we spent time with those. Here we can loop through them. Here, that's fine. Other things we do then, other built-in container types, which are nice. So this is more than just vector, right? So there's a list here. List specifically is a doubly linked list. This will make more sense once we get to doubly linked lists here. Once we start doing our own linked list stuff. So we'll build it ourselves. But the C++ list is a doubly linked list. So it's going to be fast at some things and slow at other things here. So you can push back, you can push front. Those ones are fun. So ways of storing data. You can pop from the back, you can pop from the front. You can remove a specific item, go try and find that item here, and all the things you can do here. So pretty similar, fronts and backs and things. That's the list. And we'll write our own, it'll be really fun. You can insert at a given position. So kind of like we were doing with our inserts when we had our iterator, removing things, we can insert at given positions. You can erase things at given positions with the iterators. Pairs are fun because they let you store 2 pieces of data. You have the first thing and the second thing. So when you make a pair, you get first and you get second. So it's just a way of grouping these things together. And then you can have a list of pairs, which can be kind of fun. So say, hey, I want a pair and then a type string, comma, int. So that the first thing is a string, the next thing's an int. So you can group these things together. Just a way of holding data together in a pair here. And I might argue a class is better, but this is faster than writing a whole other class to store a string and an int. Right? It's sort of an on-demand. I'm going to store these 2 things together here with a pair. Maps you'll spend more time with next semester. Map gives you a key and an associated value. Think dictionary. It's probably a better word for this. So in the dictionary, you go look up a word, and the associated value is its definition. Right? What makes them unique here is the keys have to be unique. You can't have duplicate values, right? You don't have the same word more than once in the dictionary. You just have more definitions because English is stupid, and some words have multiple meanings. I don't know why, but that's okay. So you get keys and values. So these are a lot of fun here. We can play with maps as we go. And we'll probably do some of these as we go. So you can emplace, add to it. You can get the value associated with a key. You can see if the key exists here. You can erase the key, or you can clear them all out. So we'll play with these in lab when we get there. A set is just a single list of only unique values, right? If you're a stamp collector, you want a set of stamps. You don't want the same stamp more than once. That's not very interesting to your collection. Sure. So sets do that. So when you go to add things, it gives you, I think it gives you an error if it already exists, right? If you go and add, yeah, insert. If it doesn't exist, it adds it. If it already exists, we get back the iterator to its current location. Where is it here with that iterator object? And then return false. Oh, they're chess fans. Kasparov and Fischer, Carlsen. It's the number one chess player in the world, Magnus Carlsen. But he's not the world chess champion because he decided he was bored of it and wasn't going to bother defending his title. Really interesting. And chess just made it into esports officially this year. So there's actually a lot of stuff going on. We just had an event today qualifying with a lot of prize money on the line, which is really fun. Good stuff. Good stuff. Count and size. So other things you can do with that. So they even have Nakamura. I think he's the number 2 American player. Hikaru Nakamura, just behind Fabi Caruano. All right, queues. Well, we'll write our own queue. It'll be very interesting. They're a first in, first out. Think line. When you get in line, you want the person who's in front of the line to be served first. So you get front, you get push, and you get pop. Things you can do with those. So you're very limited in what you can do. And then you'd think this would be pronounced DQ, but no, it's pronounced deck. Sure. So they're like a double-ended queue. You can push or um, take from the front, and you can push or take from the back, right? Where other ones didn't allow us to do that. So they just give you more options at either end here. And then there's a find function given some sort of structure here from the iterator, from the first iterator and the last iterator. You can go find a value in any one of these standard template libraries, which is kind of fun. It'll give you the value back. Find if is a little bit more complicated. We're going to skip it for now, but you can read about it. It's fun. You can tell it what you want to find or how you want to get that as a match here. So this function is formatted number. You can pass that as an argument to the find if. You say, hey, use this function to tell me if it's true or not. Here, not just as the value match. So it's kind of cool. And then sort. This is the built-in sort one. Sorts based on the less than operator. So when we write our own custom classes, if we override the less than operator, we can now sort, which is cool. So we can do that with our custom classes. It's to be a lot of fun when we start putting them in structures here. All right. Yeah, we didn't need a whole week for EDT containers. I think this was fine. That was pretty quick. So we've got recursion still we want to talk about. We can do that on Thursday. And then I think we're doing pretty good. Oh, we got to start the next project. Hey, we got time. Do we have time for the project? We got to wait till recursion. So on Thursday, we'll talk about the project then. And that'll be due then, not during spring break, but the 13th when we come back from spring break, because that'll give us 2 weeks to work on it. Okay. It might put us like 2 days behind for that, but it should be okay. Starting the final project on the 27th versus the 25th. I think if anyone really wanted to start early, I can give it to you early. I promise. It's okay. All right. Anything else? Cool. If not, we'll talk about recursion and the next project on Thursday. Thanks, folks.